Hey folks, Mr. McIntyre here, slowly but surely getting better. I look forward to joining you again in class next week, but for now, here's this video. Today in class, you're going to do 1.12, the velocity graph stations. So at some point soon, the graphs will be set up along the lab benches, and you'll have a chance to go visit them and do the same kind of activity we did with the position versus time graph stations. Since I haven't been in class, I wanted to go over how to read a velocity versus time graph. And so I'm going to ask you to get your packets and to find 1.12 right now. And obviously you can pause the video anytime you want. The velocity graph stations is set up in the same way as the position graph, except the graphs are different. Now, we're going to do an example together. And so the graphs say like A, B, C, and D. And so I'm going to have you cross out graph A and then write example. And we're going to like record everything in this column for this video for a graph that I drew apart from this. And then when you and your lab group go through, you're going to, instead of going to graph B, you're going to go to any graph and you're going to write down what letter that is. So make sure when you get to a graph, the first thing you do is write down the letter, and then fill out the information for that graph. And I'll say that again at the end. So here's the example graph that I drew. It's all of them are velocity versus time graph. And I'll take it away from the packet away for a second. And so you'll see like they all have 4 sections or 5, A, B, C, D, or maybe E. And the velocity is on the y-axis, the time is on the x-axis. The units might change, and so that's going to be important. And so your job is to answer the questions for each section. So let's go through that. And I'll go through everything here. So the first question is, what is the velocity of the object at t equals 0? So we go to 0 time, and we find where the graph starts. And that's at 2 meters per second. So far, we're just recording off the graph, and so make sure you write units along with every number. Next one is, what is the velocity of the object at the end of section A? We go to the end of section A, and we see that the velocity is still 2. So 2 meters per second. So this is constant velocity, just like A section, which means that this object is moving at a steady rate of 2 meters per second. Next one, for section C, this is a less informative example, but what was the change in velocity during section C? So when it says change in velocity, you want to think difference. And so the idea behind this is the change is going to be the difference between the initial and the final velocity for that segment. So I picked kind of a boring example because at the beginning, the velocity is 0. And at the end, the velocity is 0. So the difference between 0 and 0 is 0. So the change in velocity for section C is 0 meters per second. This section, by the way, is an object at rest because the velocity is 0, so it's not moving. And it moves 0 meters every second. Okay, now we get to some more interesting stuff. Find the acceleration in section B using the following steps. What was the change in velocity during section B? So again, we're dealing with change, so we're dealing with difference. And so section B is like kind of the trickiest one. So 2 is the first velocity and 0 is the second velocity. Now it's really important to note whether the velocity went up or down. And in this case, the velocity went down. So from 2 to 0. That's not a change in velocity of positive 2. It's a change in velocity of negative 2 meters per second. So the velocity of this object got lower by 2 meters per second. How much time went by during section B? It started at 25 and ends at 50. So we find the difference between 25 and 50, and that's 25 seconds. Now for part C, find the acceleration during section B. So formula. Acceleration is change in velocity over change in time. And then numbers plugged in. A equals. So negative 2 over 25. So this one's going to be small, right? Because we have like a small number divided by a large number. Negative 2 over 25 is equal to negative 0.08. So that's a really small acceleration. And we have to remember units. So you took some notes. You can always look up the units of acceleration. But I'll also tell you now, it's meters per second squared. Okay, so those are the calculations. When was the object getting faster? So one thing that's tricky about these graphs is getting faster and slower is different by a lot than the position graphs. So when the object is getting faster, that is when the line goes away from 0. So you are looking for any line where the actual line is tracking away from 0. And so if we look at A, B, C, and D, it's only D where that line's getting away from 0. So the velocity here starts at 0 and it goes up away from that. And so it goes into the more positive velocity, so that's getting faster. When was it traveling at constant speed? So I mentioned that at the beginning, but constant speed is when the velocity is not changing. And now traveling means moving. So the only answer for this one is A. That's constant speed of 2 meters per second. Technically, C is also constant speed, but it's not moving, so it's not traveling at constant speed. Tell a 4-piece story about the object's motion. So I'll leave this up to you, but the things that I want you to notice about this graph is that it moves with constant speed for 25 seconds, and then it slows down over 25 seconds. It then sits at rest for 10 seconds, and then for the next 40 seconds, it speeds up. So you can think about like maybe it's a ball that's like rolling along flat ground, and then it like rolls up a hill and stops, and so, or someone catches it, and then maybe someone like kicks it back down the hill. And so as it goes down the hill, it speeds up. So you tell a 4-part story, and that can be you being creative. So that's how this works. And I'm happy to go over everything again like next week. But I want you to try now to do this 3 times on your own. So what I want you to do is like where it used to say velocity graph B, cross it out and write letter blank. And so the next graph you go to, whether it's A, B, C, or D, write down that letter and then answer the questions for that graph. And then do the same thing on the back. So instead of visiting all 4 graphs today, you are only going to visit 3. So just make sure that whichever graph you visit, you write down which letter it is. And that's that. Good luck, and I will see you next week.